Hello, everyone. Welcome to this video in which we will tackle problem number 3, which is reshape a matrix. This is an easy problem in which we're given a list that represents a matrix, and we're given a tuple that represents the new shape of this matrix, and we want to transform this matrix from its original shape to the shape given in the input. And the output should also be a list, just as we can see here in this example. Now, in this video, I'm going to assume that you are a beginner, and so I'm going to give a very in-depth explanation of what's happening underneath the hood and what's a relatively straightforward way of thinking about this problem. But spoiler alert, as you can see here, we're loading this library Numpy, which is vital for doing machine learning and all type of linear algebra in Python. And so I'm going to also give you the Numpy solution, which is going to have significantly less code and is going to be somewhat more straightforward. But I think it's worth it to at least understand what's happening underneath the hood when you're starting out. So you get a very intuition of what's working. And if you ever run into a bug, you have any sense of how to debug it. So let's think about what's happening underneath the hood. Let's say we have this matrix M in which we have 2 rows and we have 4 columns, and we want to transform it into having 4 rows and 2 columns. As you can see here, what happens when you reshape this matrix is that the distribution of the elements change, but the elements themselves do not change. That is, as you can see, the elements in the matrix are the numbers from 1 to 8. Once you reshape it, you don't get any number 9 or number 10 popping up. It's just the same numbers, just distributed differently. And at least for me, a very intuitive way to think about this is the following. So you have this matrix here, and excuse my terrible handwriting, which has 8 elements. And this distribution is 4 by 2. I want to move it so it's 2 by 4. How can I do that? Well, one way to think about it is to first flatten this list. We know it has 8 elements, so let's stretch out this matrix so it becomes a very long vector that can hold all of the elements we want. That is, let's think about it. Instead of as a matrix, instead of the order that we have with the original dimensions, this is just a very long list or vector with all of the elements that we need. And once we have this long list, we think, hey, I want to organize this thing into a shape that's 4 by 2. I got these ones backwards. But this thing that has 8 elements, let's organize it so it has 4 rows and 2 columns. Well, you can think about having an empty matrix originally, and then you start picking elements from the flattened matrix, and you start populating this new matrix. So you start, hey, I want to grab the first element. I'm going to grab number 1. I want to grab the second element. I'm going to grab number 2. Oh, I ran out of space here because I can't keep moving in this column because I already covered the 2 columns that I have allotted for space. So instead of trying to keep moving here, I go down and start populating this new row. So where did I left off? Oh, I left off at number 3. Okay, so I start with number 3, move to 4, again, run out of space. So I go down, 5, 6, again, run out of space, 7, and 8. So once you think about it that way, it's somewhat straightforward, right? Because you can always grab any matrix, think about it as a vector, and then just start populating it in this way. Now, a very natural question that arises with this is, hey, can I do this with pretty much any shape? The answer is no, and let's see why. Let's say that instead of doing 4 by 2, I want to reshape this thing into 3 by 3. So we would apply the same logic. We would have a new matrix. I would start populating 1, 2, 3. Oops, I ran out of space. Let's go down. 4, 5, 6. I ran out of space again. 7, 8. And I don't have any extra elements to populate here. What's going to go in here? Well, by definition, you can't have a hole in the matrix. So this is going to be invalid. You cannot do this. A simple way of thinking about it is, well, why did this fail? Well, because if we wanted to distribute the matrix in this space, we would need 3 by 3 elements. We would need 9 elements total. And we only have 8. So there's no way you can fill a matrix that needs 9 elements with 8. Something similar would have happened if we wanted to reshape this thing into a matrix that's 3 by 1. In a matrix of 3 by 1, you will only have 3 elements, but you have 8. So you cannot fill this. You are going to overflow this matrix. You're going to have too many elements. So the first step when you're thinking about reshaping a matrix is going to be think about the dimensions. Do the dimensions match? So do the number of rows times columns equal the new rows times the new columns, because those are going to be the number of elements in the new distribution. These are the number of elements in the original distribution. So that should be your first step. And once you have that, then you can start thinking about all the heuristic that we talked about, which is going to be, well, think about flattening the matrix, think about how it could distribute as a single list or as a huge vector, and then just populate the new matrix. That's going to be step number 3. And so we're going to use that approach to code up our solution. And I'm going to go step by step, line by line, trying to explain how this thing is going to be implemented in Python somewhat straightforwardly. We're back in the code, and let's first write all the steps that we want to follow to solve our problem. Now, one last thing to keep in mind is that here they say that we have to return a list, and here they're giving us a suggestion to use the Numpy to list method. That's going to be good for the second way of solving this problem, but let's not get too hung up on it now. So let's write up the first steps. I always like to use comments to guide what it is that I'm trying to do, because it's easy to start typing and creating new variables and then losing track of what you're supposed to do. So first of all, we're going to check the dimensions. Afterwards, we're going to flatten the matrix, and then we're going to populate the new matrix. So to check the dimensions, what are we going to do? First, let's store in a variable the original shape of the matrix. So let's store the number of columns and the number of rows. So as you can see here, if you look at the original input A, the length of A, that is how many elements it has, corresponds to the number of rows. So here you have 2 rows. Each list here represents a row in our matrix. And then the number of columns is going to be how many elements exist within this row that you're looking at. And here, as you can see, there's 4. So that's what's going to correspond. That's why we're calling that's how we're creating these new variables that are storing the rows and columns. Afterwards, we're going to create the variable that's going to store the new rows and the new columns. And we're giving that as an input in new shape. So we can just simply do this. If you have multiple values in Python, you can unpack them to multiple variables so long as the numbers match here. So first step is going to check that the number of elements in the new arrangement that we want equals the number of elements in the original matrix. How do we do that? Well, if rows times columns equal new rows times new columns, then we're okay. We want to stop the program if we find that this is not the case. So we do this to say that they're not equal. And there's multiple ways you can handle this. You can return a -1 or any other value. I'm just simply going to raise an error. This is going to be because this is going to, if you ever run into this problem once you're running your code, then it would be easier to debug. Incompatible shapes. Great. So if the dimensions do not match, then rather, if the shapes do not match, then you just stop iterating. Assuming that that does not happen, then our next step is going to be to flatten our matrix. And so what we're going to do is we're going to initialize a flat matrix as a list. Remember, we want this very long vector that's going to store every single element in the matrix. And so we're going to iterate over all the rows that we have. We're going to iterate over all the columns that we have. And we're simply going to add those elements to our flat matrix, which is going to be a list. And once we do that, we're going to have all of the elements stored into the flat matrix, which is going to be this variable list. Finally, what we want to do is we want to populate this new matrix. So we're going to initialize this new matrix as an empty list. And we're going to also initialize a variable that's going to be called index. Now, what is index going to do? This is going to tell us the position that we're in the flat matrix. That is, to which element we're looking at in order to add it to the matrix. the new matrix. And now, as a homework for you, this variable is not strictly needed. You could have make do by just keeping track of which row and which column you're in. But just for the sake of simplicity in this video, I'm just going to use this variable. And it's a good exercise to think about whether this is needed or not and how you would get rid of it. So similarly to what we did before, we're going to iterate over all of the new rows that we need to populate a matrix. Remember that if you're representing a matrix as a list of lists, then every row is going to be a list. So we're going to initialize this new row as an empty list. And then for every new column in the range of the new columns, we're going to add these elements. So new row dot append, and we're going to call flat matrix index. So we're saying to this new row that started empty, as long as you have space, that is, as long as you do not go beyond the new number of columns, you're going to add to this new row the element that you're looking at in the flat matrix, in the very long list of all of the matrices that you had. And once you add that element, you want to look to the next element in the flat matrix. So we're going to increase the index by 1. And once you go through all of the elements in the new columns, what we're going to do is we're going to add that element to, we're going to add that row to the reshape matrix. So once you get out of this loop, you're going to add it here. And then once you finish iterating, you're going to be good to go. Now, let me just check that everything's okay. There's no errors on the variables, and we're going to submit our code. Now, this is going to take a while to run because there's a lot of loops, and again, it's not as efficient as it could be. And oops, I made a mistake in the name. Instead of calling it reshape matrix, I called it reshape matrix. Let me try again. This kind of thing always happens. And as I was saying, this is going to take a while. Now it works, it's accepted. It all works well. As I said before, this is going to take longer than the other method because you're doing so many loops and so many iterations, but it works. And it's a good way to understand what's happening underneath the hood. Now, we already solved it the long way. What's the simple way of solving this? And this is going to be very useful because, again, you have to get familiar with Numpy because this is going to make our lives easier. As I said before, Numpy is going to have a lot of built-in functions and methods that are going to make working with matrices simpler. So first of all, we have a list of lists, and Numpy has its own way of representing data, which is called a Numpy array. So let's first transform our matrix into a Numpy array. And you do it by calling np to call the library.array, that's the function, and then you give it the list of lists as an argument. Now, once we have that, we can call a very conveniently named function that's within Numpy, which is called reshape. And what does reshape take as an input? It takes a tuple, which we're already given as the input in our function. So we're going to do this, dot reshape, parentheses, new shape. And because we want to return this as a list, we have to take the hint that's written in the comment, and we just call the toList method. And with that, you are going to solve the whole problem in just one line of code instead of what we did before. So we're going to run this. It shouldn't take as long as it did before, but underneath the hood, I'm not entirely sure if it does it the same way as we did, but it does somewhat similar. And it's going to also raise an error if the dimensions do not match. So as you can see here, all of the test cases were accepted. This is way faster. This is what you should be doing if you're working in kind of production. But in order to properly understand or just not copy and paste code, it's good to think about what's happening underneath the hood. So that was the video. Thank you guys very much for your attention, for being here. And I hope to catch you on the next video.